Hello students, if you are stuck on your static homework, this is the one video you need to watch. We are going to break down this tricky truss problem step by step, showing you exactly how to find the forces in every member. Okay? Let's dive into this. Okay, so first of all I will take joint B. This is my joint A, and this is B, and this is C. Okay, so I will take joint B, okay, to find the force in member AB, okay, and BC. So I first of all I will draw a first free body diagram FBD of joint BD. Okay, so one is the force, which is load exerted downward, vertically downward, and the other is at an angle of 15 degree. Okay, so this is at an angle of 15 degree. I assume that this force is in free body diagram of joint. This is a tension, this is in tension, and this is at 45 degree with x-axis, and I also assume that it is also in tension. So if the answer is with the negative sign comes and the force find it with a negative sign, that means that my assumption was wrong. Its direction is upward, and this is in this will be in compression. Okay, so I assume that this force and the force in this member and force in this member is in tension. Okay, so this is force FBC. Okay, and this is force FAB. Okay, so first of all you need to resolve this into its component, because this is not a pure horizontal or pure vertical. So some kind of force and some part of this force will act horizontally, and some part of this force will act vertically, and also this member also some part of force vertically act vertically and some part of force act horizontally. So first of all I will take this member, okay, F. This is a resultant force, which is FAB, and this is its horizontal component, which is FAB cos 45. Okay, 45 degree, and this is its vertical component, which is FAB sine 45. Okay, these two forces were component of this member. Okay, and also I will resolve it into its components. So I will take this is the resultant force FBC, and this is its vertical component, which is FBC cos sine 15. This make an angle of 15 degree. Okay, and this is FBC cos 15 degree. Okay, so now take summation of all forces, horizontal or vertical forces Fy equal to 0. I take summation of all vertical forces equal to 0. Let's say the force directed upward take positive, and the force directed downward will take negative. Okay, this is science convention. So there is one vertical force, and another vertical force is this, and the another vertical force is this W. So there are three vertical forces, FAB sine 45, okay, component of this sine 45, and FBC sine 15. This is directed upward, which is positive, and this is directed downward, which is negative. FBC sine 15 degree. Okay, and the other is negative W equal to 0. So I will solve it. This is equation 1. So summation of all horizontal forces Fy Fx equal to 0. Okay, so F AB cos 45 degree and FBC cos 15 degree, which is negative. This is also negative. The force directed toward left is negative, the force directed toward right is positive. So FBC cos 15 equal to 0. Okay, so I will put the value of AB in this equation. Okay, or let's say write it in this form. So it's gonna be very easy because there is only two forces. So FAB will equal to negative FBC cos 15 degree, FBC cos 15 degree divided by cos 45. Okay, if you calculate this on calculator, cos 15 divided by cos 45, so what is this? Cos 15 divided by cos 45 is 1.366. So I can write this FAB equal to negative 1.366 FBC. Okay, so I put this equation in this. Can I put this equation in this? FAB in this equation, this. Okay, so if at the place of FAB I will put 1.366 FBC. So take this, FAB at the place of FAB is negative 1.366. Okay, 1.366 FBC multiply sine 45, sine 45. Okay, and the other force is negative FBC sine 15 degree. So negative FBC sine 15 degree. Okay, and negative W equal to 0. So can I common FBC from these two members? So from these two forces, so I common FBC. Okay, negative 1.366 multiply sine 45 degree negative sine 15. Okay, equal to W. I shift this to the right side. Okay, so FBC, if I calculate this, so if you minus 1.2247, okay, negative 1.2247 equal to W. So I shift this to the both side, 1.2247, 1.2247. This will cancel with this and negative. So this will become FBC will become equal to 0.82 W. Okay, this is my force in member FBC. In this member the force is 0.82. So when I assume that this force is in tension, so this is not real in tension, this is in compression. So this force will be in compression. Okay, so this will squeeze down, compressed. Okay, if the load is applied here and there is a support, so the force in this the member force exert the force is exerted in this member and the member try to compress. This member try to compress. Okay, sorry. And you can put, so you will put this FBC 0.82 W in this, FAB. So you will get the answer of FAB. So FAB, AB will equal to negative, at the place of FBC I will write this negative 0.82, sorry, 0.82, negative 0.82 multiply by negative 1.366. Okay, so if you calculate this, FAB equal to, if you calculate this, so if you calculate this, this is W. If you calculate this, it will comes positive 1.117 W. Okay, you are getting two forces in member. So this is positive, it means that my assumption was right, this member is in tension. Okay, so it is a 1.117 W. The load is exerted at this member is 1.117 W. Okay, so there is one member left, which is this member. So for this member I only and only make coordinate align coordinate. So this is at 30 degree, this is my 30 degree. If this is 15, this is 30, 45, it will become 45. Okay, so this is 30 degree. Okay, so if I push this 30 degree, I align its coordinates. So okay, so this is y coordinate and this is my x coordinate, not this coordinate. Okay, so this will be simple for me. So this is my x coordinate. Now I find, so this I push this 30 degree to here, this is my y coordinate. Okay, for this joint only y coordinate. So x and y, I align with x and y coordinate. This member is aligned with y coordinate. So now what we will do, we will do the find this value. So if I push this to this 30 degree, it will comes out 30 degree here. This is 30 plus 15, this whole will be equal to 45 degree. Okay, this whole will be equal to 45 degree. Now I make joint joint, joint C. I will take joint C. At joint C, I assume that this BC is in compression. Okay, this BC is in compression, this force is BC. Okay, and this is the reaction force. Okay, this is the reaction force FXC. Okay, and this is AC, which is also in compression. I assume that it is in compression, FAC. This is my FAC. Okay, so I will make coordinate like this. X coordinate will align with FXC, this reaction force, and the y coordinate will align with this force. So the force will exert at this point only by the horizontal component, this component F. This is FBC and this is its component FBC cos, this is 45 degree, so sine 45 degree. Okay, and this is FBC cos 45. Okay, now I will take this joint. So summation of forces F, all horizontal forces X equal to 0. Okay, so if the force exert only this component will resist this component. If the force exert FBC cos 45 degrees, so FBC cos 45 FBC force is 0.82, and I will multiply this with cos 45. So FBC 0.82 multiply cos 45, so the force exerted at this point 0.57, so 0.58. Let's say this force will, this component have 0.58 W, so Fx will be equal to 0.58 W. Okay, so this will cancel with each other, cancel out with each other. So if I take summation of all vertical forces equal to 0, so there is two vertical force FAC, this is FAC which is aligned with the axis, so this is pure vertical, and this component FBC negative, this also negative, FBC sine 45, okay, equal to 0. Only these two components, only these two forces are here, vertical forces are here. So FAC will equal to negative F, I shift this negative to here, FBC sine 45. Okay, so FBC value is, I know FBC value, FAC will become negative, FBC is 0.82, so this will become negative 0.82 sine 45 is sine 45. So if I calculate it on calculator, FAC will becomes equal to 0.58, okay, W. So we find all the forces. FAC is